students, the new topic of ours and the last topic of this chapter is the density and relative density of an object. As the name suggests, one part is the density and one part is relative density, that is relatable to anything. So here, what is density? First of all, let us see that. Here we are having a cube box that is made up of iron, and here that is 1 kg of weight. And again, I have taken 1 kg of cotton. Now, if I ask you which weighs more, okay, some students says, ma'am, iron part weighs more. Okay, now students, I have already told you that these two are containing same amount of weight. Okay, so we can say in terms of weight, they are both of equal weight. Okay, now, but if I ask you which occupies more space, okay, now that part comes to the idea that space means the area covered. Now, the solid part here that is made up of iron is just containing a specific part, and this, because it can lose its each and every part, so we can say it occupies more space. Yes, students, so here we deals with the term density, and now let me tell you how we can compare these two in terms of density. Okay, so what is density actually? Density means the mass of an object per unit volume, and here we are having the formula mass upon volume. Okay, so as you know, earlier we are having a iron here and a cotton here. Okay, so that iron is having the 1 kg mass and that cotton is again having a 1 kg of mass. But the space, that is the volume part, is limitized by this. Let's suppose it is having a certain value, let's 5 meter cube. Okay, that it is very big value. Okay, let me tell you 5 centimeter cube. Okay, now cotton can spread. Okay, now we can say that it is 10 centimeter cube part. So now the volume of the cotton is more compared to the iron, but the weight part contained in these two volume is equal. Okay, so now as you can see, is small and the large part. Okay, now in this small box and in this large box, in this also 1 kg of weight will get immersed, and in this part also 1 kg of weight is get immersed. But containing in this part, the molecules will get very close to each other. Okay, बहुत पास होंगे, because in a particular small volume we need to contain 1 kg. Now in this very large volume we can contain 1 kg very easily. Okay, it can be easily get spread. So now here the density part comes. We can say the density part of this iron is more compared to the density part of this cotton, because when we divide these two numbers, these will get a less value. Like here we are having a 0.2 number and here we are having 0.1 as the answer. So by the answer you can check that this part is more. So you know mass upon volume is density. So we can say that the density of iron is more and the density of the cotton is more. So students, by this example, I guess you get to know that what is density part. Even in like social subject also, you are having a geography part. Now in that also you have heard that the dense forests are present. Okay, what are these dense forests? Dense forest is like if we contain certain area, if we're talking about a particular area and that particular areas are having numbers of trees here. Okay, and one more particular areas. So let's suppose here we are having only 50 trees and here we are having thousands of trees in that same area. We are having two equal areas. So now we can say that the space part, that is the volume part, is same, but the mass value, like here only 50 and here 1000. So which one is get dense? So this will be the dense. So that is how we can say that for a particular area, if number of trees are more, so we will say that a dense forest. In the same manner, if we are talking about at the molecular level, so for a unit volume, if we are taking 1 meter cube, this is 1 unit volume. for this unit volume, the mass that has been contained in this volume will gives you the idea of the density of that object. Okay, if the mass is more for this volume, density will more. If the mass is less for this volume, the density will be less. So density is nothing but for a particular volume, number of molecules present there gives you the idea of the density. And for a comparison, we can even take that water and honey. We are having two examples. So water and honey, which one is more dense? Obviously honey, because if we are taking the equal volume of these two products, so this will have more thickness. Why? Because more number of molecules and atoms are present for that particular volume in this case. So we can say here that the density part of the honey is more compared to the density part of water. Now students, here is a list of different densities of different objects. So as you can see here, we are having the density part that is in increasing order. No, not in increasing order. Okay, so let's suppose we are having a air here. So air is 0.0013, okay, in a centimeter cube. Centimeter cube means 1 centimeter. If you are taking a cube box, okay, so 1 centimeter, 1 centimeter, 1 centimeter. If you are making that small cube, this is 1 centimeter cube, okay, very small. Even you can measure it with your scale. You are having a ruler, you are having 1 centimeter here. So the length part, breadth part and the height part all are 1 centimeter. So we can say 1 centimeter cube is here. If in that 1 centimeter cube we are having that much of mass of the air, that is 0.0013, that is too small, even negligible mass, 0.0013, okay. So that smallest part is the density of the air here. In the same way, we are having the wood, that is 0.85, water for 1, okay, that is equivalent. That means 1 and 1 divided by 1 gives you 1. So we can say 1 gram of water can be contained in 1 centimeter cube of volume. That is why we are having water as a 1 density. Okay, ice 0.93 less dense compared to the water. That is why ice floats on water. When mama gives you drink to there is a drink, soft drink, so if the ice is here, then ice will float on it, right? Why? Because it is less dense compared to the water. Volume part get increased, nothing happens here because the volume part here is more compared to the liquid part. So the number of molecules were the same earlier also and now also, but volume part get increased. That is why it get decreased in the density. Aluminium is 2.7, lead is 11.3, gold is 19.3, ethanol 0.94 and methanol is 0.79. So this is the different densities of different objects. Okay, now relative density. As you know that in this cube, volume cube, we were having 1 gram of water, okay, and if relative density of this is mass upon volume, so 1 gram get divided by 1 centimeter cube will gives you the 1 gram per centimeter cube, that is value 1. So we can relate any object with this 1 value, because people that any number in mathematics, any number get divided by 1 will gives you always the answer of same. Okay, like 5 is get divided by 1, you will get 5 again. Now, if you want to relate any density with water, you will get the same answer. If I want to relate ice by the water, so if I divide it by this, so I know that ice is 0.93 and it is 1. So again I will get the same answer, 0.93. So it will not going to change anything. But relative density is what? It is just a comparison between the density of any object with the water density. Okay, that is why we have compared it with, because it is not going to change any of the value of the above object. Okay, so relative density is what? Density of object that is related to the density of water, or we can say that we are actually comparing these two densities. When what with the density of the water. Any object density get compared with the water density, we can say that this is the relative density. Okay, so here why we have taken water only? As I have told you, at room temperature we are having 1 gram per cubic centimeter as the density of water. That helps us in taking this 1 gram as the relative density. Now let us do one example on it. Okay, let's suppose relative density of iron and is this. So we are having the relative density of iron kg per meter cube. Like students, one more thing I want to tell you, gram per centimeter cube. And if you need to take some higher standard like kilogram, because gram is a small unit, so if you are going to change this as a kilogram, then this centimeter part will also be get changed and it will change into the meter part. Okay, so relative density of iron is this. Relative density of coke is 240 per 1000, that is the 0.24 kg per meter cube. And how does we compared it? Because we know 1 gram per centimeter cube is the density of the water. Now, when we are taking it into kilogram per meter cube, so we need to convert the value 1 gram into like kilogram. So we need to divide it by 1000. Okay, that is why the iron part here get divided by the 1000, and now we are getting 7.8 kilogram per meter cube, and coke here we are getting this part. So coke is what? That we used to play with the badminton. Okay, that coke. Okay, so coke is lighter, and that lighter part again, if we relate it with the liquid density, now it is just this part of the liquid. And if we relate it iron to the liquid, that is water, so it is 7.8 kilogram per meter cube in compared to the water density. So this is the example part. So students, here we are having a diagram. As you know, the iron part, the relative density of the iron was 7.8 kilogram per meter cube, and this coke part was 0.24 kilogram per meter cube. Okay, now as you can see, 7.8 value, it is greater than 1, and as you can see 0.24, it is less than 1. So this gives you an idea that which object will float on the liquid, on the water, and which object will sink into the water. More the density will sink, like the iron is sinking, and less the density, relative density, like why we have related it, related just to check whether it will sink or float. Now, because this value is less than 1, so we can say that the coke part is here floating on the water part. Okay, as water is only 1 gram per centimeter cube, it would be easier for us to compare this one. Okay, so now students, as this chapter is over and now we are having a MCQ part, don't forget to practice more and more at home and revise this chapter again with a great effort. Happy learning. Thank you.